Hi there, welcome back to another Papetti Math YouTube video tutorial, where today I am going to be teaching you, yes you, Algebra 1. And in this video, we're going to look at exercise number 4, where we're going to factor completely. And what that means is that we're going to keep on factoring until we cannot factor anymore, using the ideas of trinomial factoring, but more specifically, difference of two squares and GCF factoring. So let's take a look at part A to see what we're being asked to do right now. And we want to ask ourselves first, is there a GCF here? And we look at these two terms, and there is no GCF. So now, is this a difference of two perfect squares? And your answer is yes, it is. So what is the square root of x to the fourth? What times what will give you x to the fourth? And the answer is x squared times x squared. And what times what will give you 81? And that's an easier one. That's 9 times 9. We separate that with a plus and a minus. Now we look at each of these. And are either of these sets of parentheses able to be factored? And you should notice that this one is, because this one is also a difference of two perfect squares. Remember from exercise number 3 that this is a sum of two perfect squares. This one cannot be factored, so we're just going to bring it down. And then this one is a difference of two perfect squares. So we could go ahead and factor that as x and x, because x times x is x squared. 3 times 3 will give us 9, and separate this with a plus and minus. So this is factored completely right here. All right, let's take a look at part B now. Part B, we want to ask ourselves, is there a GCF? And yes, there is. The GCF here is 7. And we divide each term by 7, and we are left with x squared minus 4. Look inside those parentheses. Can it be factored further? And the answer is yes, once again, because inside those parentheses, we do have a difference of two perfect squares. So we're going to have x and x. 2 times 2 will give us 4, and separate those with a plus and a minus. This is factored completely right here. And finally, part C, do we have a GCF? And I don't believe so. Is it a difference of two perfect squares? And yes, it is a difference of two perfect squares. And we'll get into this in just a moment. But what times what is 16x to the fourth? Well, we know that 4 times 4 is 16. We saw over here that x squared times x squared is x to the fourth. So 4x squared times 4x squared is 16x to the fourth. And now finally, 625 is a perfect square because 25 times 25 is 625. Once again, separate with a plus and a minus. Now, we look back and we see, do we have another difference of two squares here? And our answer is yes, once again. This is a sum of two squares, so we just bring it down. We can't do anything further with this, 4x squared plus 25. But then we can factor this one right here, because 4x squared is a perfect square. What times what is 4x squared? So that's going to be 2x times 2x. And what times what's 25? And that's 5 times 5. And we separate those with a plus and a minus. So factored completely, this should read 4x squared plus 25 times 2x plus 5 times 2x minus 5. And that concludes our exercise number 4. And if this video is helpful for factoring completely, when we had different powers and coefficients in front of our a term, or as our a term, not in front of our a term, give this video a thumbs up. And you're not ready for the last type of factoring that we're going to see in this lesson, and that's going to be factoring perfect square trinomials in exercise number 5. Thank you for watching.